we're going to be looking at the Pythagorean theorem. So the Pythagorean theorem is the backbone for trigonometry, and it's also a really important topic all through grade 10, grade 11, grade 12, and also some of grade 9. So Pythagorean theorem is essentially revolves around the right triangle. The right triangle, as you may have learned, is a triangle where one angle is equal to 90 degrees. 90 degrees. And it's called a right triangle because an angle is equal to 90 degrees. A right triangle looks like this, but as long as it has to have 90 degree angle, which is represented by this little box right here. Box, right? And so our Pythagorean theorem formula is a squared plus b squared is equal to c. Now you might be a little confused right now, but what is this formula, right? I'm gonna get to that in just a minute. So let's get back to a triangle. Then a triangle, we know it's a right triangle. Always one angle is always equal to 90 degrees. And when that angle is equal to 90 degrees, the other two angles always have to be lesser than 90 degrees. Lesser than 90 degrees, right? And when they both add up as well, they have to equal or be less than 90 degrees. So 90 degrees, right? So let's get back to our Pythagorean theorem right here. Our Pythagorean theorem helps us find the length of an angle, the length of a side of a right triangle when we know two sides. So for example, I have this right triangle right here, and they've given us this side is equal to 3 centimeters and this side is equal to 4 centimeters. This is a perfect case for Pythagorean, and this will help us find our our side C, our side C. So why not go ahead and solve this? Let's go ahead and solve this. This will be our first example. So A and B can be any of the sides except the hypotenuse. The hypotenuse is always C. Always has to be substituted for C. In this case, we have 4 and 3. So I'm going to use A as 4. I'm going to represent A by 4. So substitute A with 4, 4 squared. By 3, I'm going to substitute with B, 3 squared. The A and B are interchangeable as long as you're consistent. They can be any of these values. We don't know C squared. That's what I'm trying to find. I'm trying to find C. 4 squared is equal to 16. 3 squared is equal to 9. All the T squared. 16 plus 9 is equal to 25. And my 25 is equal to C squared. Now I don't want C squared. I want to find just C. So to find just C, we have to root the whole equation, because when we root the equation, our square and our root cancel out. So we're left with root 25 is equal to C, and our C is equal to 5. Extremely simple. That's how we found it out. And now we know that our hypotenuse is again the angle that is opposite from this box, from our 90-degree angle. This is our hypotenuse. This is our hypotenuse. This is our hypotenuse. Our hypotenuse is the side that is opposite to our 90-degree angle, equal to hypotenuse if you notice. So our hypotenuse is equal to 5. Hypotenuse of this triangle is equal to 5 centimeters. So that's a good example of our Pythagorean. This is actually a 3, 4, 5 triangle. Our 3, 4, 5 triangle, and this is always the case. This is one of those triangles that it's always 3, 4, 5. So if you know that the two sides are 3, 4, then you know the hypotenuse is 5. So let's move on to another example. Let's take another example. So feel free to pause the video whenever you want and try the example on your own, right? That's going to help you. So this again is our hypotenuse. They've given us the hypotenuse is 9 centimeters, and they've given one side is 3 centimeters. So again, a squared plus b squared equal to c squared. I'm going to say my 3 centimeters is a. Again, you can use it for b. It doesn't really matter. So 3 squared is equal to, oh sorry, they're trying to find x. They want us to find side x. They want us to find side x. So right here I have 3 squared, which is my a squared, and I'm trying to find my b squared, or my x squared, in this case the variable that they're given us, which is equal to 9 squared. 3 squared is equal to 9 plus our x squared is equal to 81. 9 times 9 is equal to 81. Now it's an easy linear equation right here. We have to subtract 9 from both sides, keep it even. X squared is equal to 81 minus 9 is 72. Now again, we know now x squared is equal to 72. However, we don't want to find x squared, we want x alone. So to find x, we have to square root both sides of the equation, and our square root and our squared cancel it out, so we're left with x is equal to root 72. And now our root 72 can be simplified. Now radicals, you might not have come across radicals yet. However, radicals, essentially we have to find the prime factorization of 72. Our prime factorization of 72 is 9 times 8. Our prime factorization of 72 is 9 times 8. 3 and 3, 4 and 2, there we go. That's our prime factorization. Now we just write that in. We have 3 times 3, and we have 3 2's. Now when it's a pair, when you have two of the same number inside our radicals, like this or like this right here, we take them out. So we take out our 3 singular 3 and left with 3 2's inside. Again, we have our pair, we can take one out, times this by 2, so 6 root 2. That's completely simplified because 2 is a prime number, we cannot factor that. 2, 1 and 2, there's no 2 common factors, so that's pretty much it. And our 6 root 2, our 6 root 2 is actually our x, right? So we have successfully found x. The side x is equal to 6 root 2. Now I'm gonna leave you guys with another example just so you can get more thorough with the Pythagorean theorem. Here's another example for you guys. So feel free to note this down, write it down, or just put it in your head if you can, right? Again, right, hypotenuse right here. They've given us our hypotenuse is 12 centimeters. They've given us our other side is 6 centimeters. This one's a little more tricky. So this one is your question for the day, and have fun with that. So that was Pythagorean theorem for you guys. So thanks so much for watching. Make sure you subscribe. Thank you.